Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video, we are going to learn how to write prime factorization of a number. In fact, by the end of this video, you will be able to solve these examples that you can see in the first slide. Before I start solving examples, it's important to get familiar with the definition of prime numbers. Prime numbers are natural numbers. They are greater than 1. It means 1 is not included. And they have exactly two positive divisors, 1 and themselves. Okay, you can see a group of prime numbers from the least prime number. 2 is the least prime number, and we have up to 29. Yes, after that we are going to have prime numbers, but I didn't write them here. What does it mean, prime numbers? Look at the number 11. 11. Is it divisible by 1? Yes, all the numbers are divisible by 1. Is it divisible by 2? No, because it is not even. Is it divisible by 3? No, because if we add the two digits, we are going to have 2, so it's not divisible by 3, it's not divisible by 4, 5, 6, 7, 8, 9. You can check it. 10. And finally, it is divisible by 11. Every number is divisible by itself. So it has two positive divisors. So 11 is a prime number. There is a question here. Do we have to memorize them? Yes, it would be really good if you memorize a small prime numbers. For example, from the least one, 2 to 29. If a question asks you 17 is a prime number, without thinking, you must be able to say, yes, 17 is a prime number. But sometimes a question may ask you larger numbers, for example, 59. Okay? In that case, you do not have to memorize that. It happens rarely. And in that case, you can calculate that. You can check if it is divisible by any another number or not. So I expect you to memorize prime numbers less than 30. Let's solve the first example. Look at my method. My method is much more easier than other method that you have seen. You can draw a Christmas tree. You can use, I do not know, samurai method or whatever it is. But I strongly believe that my method is really, really easier. And if you have some examples, you will realize that it has really higher speed. Okay, first you must write the number 36. Then in front of that, you must draw a straight vertical line. You must check it. Is there any prime number that I can divide 36 to that? Let's check what is the least prime number, 2. Is it divisible by 2? Yes, because it is even number. So if I divide 36 by 2, what would the answer be? The answer will be 18. Now I continue this process with 18. Is there any prime number that I can divide 18 to that number? Yes, again 2, because it is even number. After that, I'm going to 18 divided by 2, it's going to be 9. Is there any prime number that I can divide 9 to that? Let's check with each other. The smallest one is 2. So I cannot divide 9 by 2. Let's check 3. Yes, I can use 3. If I divide 9 by 3, the answer will be 3. Is there any prime number? Yes, again 3. And 3 divided by 3 will be 1. When you reach to the 1, you must stop the process. So here, stop the process. Now I can write 36, which was the first number, as, look, the first number is 2. The second number is 2 again, multiply. The third number is 3. And the fourth number is 3. This is the prime factorization of 36. Or I can write it again, 36, like 2. How many 2's do I have? 2 to the power of 2 times 3. How many 3's do I have? 2. So this is the prime factorization of number 36. There is a question here. Here I start by dividing 36 by 2. But at the beginning, I could choose another number. For example, I could choose 3. Is there any difference if I start with 3? No, there is no difference between them. But I prefer to start with the smallest prime number. But if you prefer to start with dividing by 3, there is no difference between them and your answer will be totally correct. 72. Again, I'm going to write 72. I'm going to draw a straight line. Is there any prime number that I can divide 72 to that? I start with checking by 2, which is the smallest prime number. Yes, I can divide by 2 because it is even. If I divide 72 by 2, the answer will be 36. If I divide, is there any number that I can divide 36 to that? Yes, 2 again, 18. Again 2, 9, again 3, this time 3 is going to be 3, and divided by 3 is going to be 1. When I reach 1, the process will be stopped. Now I can write 72 as, look at the first number, 2 times second number 2 again, third number 2 again, fourth number 3 again, 3 this time, and the last number 3. Or I can write it as 72 is equal to, how many 2's do I have here? Look, 3. So 2 to the power of 3 times 3 to the power of 2. And this is the prime factorization of 72. Look at the next example. 236. And I must draw a straight line. Is there any number that I can divide, any prime number that I can divide 236 to that? Yes, it is even and the smallest one is 2. After dividing by 2, you can divide in another way and find the answer in another space. It's going to be 118. Again, I can divide it by 2 and I'm going to reach to 59. Okay, this can be a little bit tricky. Is there any prime number that I can divide 59 to that? 2 is not going to be the number, 3 is not going to be the number, 5 is not going to be the number because the last digit is 9. And 7 is not going to be the number. If you check some prime numbers, you will realize that 59 is prime. So when it is prime, I must divide it to itself. 59 divided by 59, and I'm going to find 1. When I find 1, I must stop. So I can write 236 is equal to, the first number was 2 times 2 times 59. Or I can write it as 236 is equal to 2 to the power of 2 times 59. And this is the prime factorization of 236. Look at the next example. 225, a straight line. Is there any prime number that I can divide 225 to that? Yes, you may think to yourself that it is really easy. The last digit is 5, and when the last digit is 0 or 5, it is divisible by 5. But I told you I prefer to start with the smallest prime number. 2 is, of course, it's not going to be the case. But if I add all the digits, 2 plus 2 will be 4, plus 5 will be 9. I will realize that it is divisible by 3. So I'm going to start with 3. After that, I'm going to have 75. Is there any prime number that I can divide 75 to that? 2 is not going to be the case. By adding 7 and 5, I'm going to have 12. Of course, it is divisible by 3, so I'm going to have right 3. If I divide 75 by 3, the answer will be 25. Is there any prime number that I can divide 25? Yes, 5. After that, I'm going to have 5 divided by 5, 1. When I find 1, I must stop. So I can write 225 as, look, I'm going to write the final answer in one step. I have 2 3's, so 3 to the power of 2 times, and I have 2 5's. 5 to the power of 2. This is the prime factorization of 225. We have 180. I'm going to mention really important point here. Please pay attention. If you have 0 at the end, if you have 0 at the end, the last digit is 0, okay? You can write 2 and 5 and then drop the 0. Drop the 0, write 18. And then you can continue, okay? So now, is there any number? Yes, 2. 18 divided by 2 will be 9. 9 divided by 3 will be 3. And 3 divided by 3 again will be 1. And I will stop the process. So I can write 118. As I told you, 0 must be in the last digit. Last digit, not in the middle of the number. So I can write it as, how many 2's do I have? 1, 2. 2 to the power of 2. How many 5's do I have? 1. So 5 to the power of 1. And how many 3's do I have? 2. So 3 to the power of 2. And this is going to be the answer of this question. Look at the next one. I have 1300. I told you, if you have 0 in the last digit, you can write 2 and 5, then drop a 0. But here you have 2 zeros at the end, so I must write 2 2 and 5s. And then I am able to drop 2 zeros. 1 2 and 5 for this 0 and 1 2 and 5 for the next 0. So if I drop 2 zeros, if I eliminate 2 zeros, I'm going to have 13. 13. Is there any prime number that I can divide 13 to that? Look, you must divide to a prime number. Please do not divide to other numbers. Yes, it is divisible by 13 and the answer will be 1. So I stop the process and I can write 1300 like, how many 2's do I have? 1, 2. So 2 to the power of 2. How many 5's do I have? 2. So 5 to the power of 2 times, and I have 113. This is the final answer of this example. Here you can find more examples and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write them in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.